Hello, geometry. We are moving on to our final unit for the semester. We are going to be doing the Unit 13 materials. Now, none of that stuff has been photocopied and given to you. So you're going to have to pull out these materials from the Unit 13 folder in Canvas. If you can print out these note sheets and worksheets, great. If not, you can do these notes on your own paper. This whole unit is going to deal with area at the beginning, and then we'll get into surface area and volume. So let's go ahead and get started. Area is going to be the number of square units that fit inside a figure. And I'm sure you've probably done area before in previous math classes. The units are always going to be squared. So you'll have something like square meters, m with a little 2, or square feet, or square inches, or square yards. It's always with a little exponent of 2. The area of a parallelogram. Okay, we learned about parallelograms a long time ago. This is also going to hold true for any kind of rectangle as well. Okay, because a rectangle and a parallelogram, or even a square. All right, you can use this formula. It's going to be area equals base times height. So the base is the one side, the height is the other. The base and the height are always going to make a right angle with each other. Okay, and I'll explain that in the pictures below. All right, so if you have a rectangle, base times height, no problem, base times height. If you have a parallelogram like this solid figure is, you would need the base, and then you would need the height. The height would not be this piece here, because it's not directly going from the top to the bottom. We want the shortest distance between the top and the bottom. That would be the height. So base times height is the formula you're going to need. When working with a parallelogram formula, remember that it will also apply to a rectangle, which I mentioned. Oh, I didn't mention this one. Rhombus and a square. Remember, a rhombus is kind of like a leaning square. When dealing with any type of parallelogram, the base and the height are always perpendicular. So you want to make sure your base and your height are perpendicular. So in number 1, you'll notice that we have these two measurements. 6, you can tell, is the height of this either rhombus or parallelogram. It's kind of hard to tell. And then this guy is your base. You're just going to do base times height. 6 times 11. You'll get 66. Units are centimeters, and it'll be squared because area is always square units. This one, we're finding the area of this parallelogram. It gives you some dashed lines here. All right, you have to be careful because you're not going to use every single number. The base of this parallelogram is going to be 10. Okay, it's the bottom piece of this parallelogram. The height is not going to be 17 because, again, we want the shortest distance from the top to the bottom. The shortest distance from the top to the bottom is going to be represented with this dashed line here. That's the height. All right, that's the height of our parallelogram. But I don't know what the height is. 15 is not our height, but 15 is going to help us. What we're going to do is we're going to focus on just a certain portion of this picture. We're just going to focus on this triangle here. All right, if you notice, this is a right triangle. When you have a right triangle and you know 2 of the 3 sides, we get to use our favorite Pythagorean theorem. A squared plus b squared equals c squared. C is always the hypotenuse, so c is 17. You're going to do h squared plus 15 squared equals 17 squared. All right, hypotenuse is always across the right angle, so make sure C is the hypotenuse. I'm going to skip the work for this, but you're going to get h equals 8. All right, you just square them, subtract, and square root. All right, actually maybe I should, just because I feel like some of you might have forgotten how to do this. You got h squared plus 15 squared is 225. 17 squared is 289. You're going to minus 225 from both sides. You get h squared equals 64, and then to get rid of the squared, you square root it. That's how you get h equals 8. So our height is 8. We know that our base is 10, and now we can finally get to the area. The area is base times height. 10 times 8, you're going to get 80 square meters. Don't forget to square your units. All right, let's go down here. Area of a triangle is 1/2 base times height. So very similar to the last formula. Now, just like with a parallelogram, the base and the height in the triangle must also be perpendicular. The height, or the altitude, of the triangle can be inside, outside, or on the circle. Altitude is the height. Now let me show you what I'm talking about. So we've got this triangle here. The base is going to be this entire side here. So it's not just 6 or just 11, the whole thing is 17 if you add them together. The height is the distance from the top of the triangle to the base. Notice it's perpendicular, so our height is 5. The area is 1/2 times the base, 17, times the height, 5. Multiply those out, you will get a decimal, but that's okay. It's 42.5 square feet, square units for area. The base of an isosceles triangle, so let's draw this out. The base of an isosceles triangle, so isosceles means two of the sides are congruent, is 18 centimeters. If both of the legs, so the legs are the two congruent sides, are 41 centimeters, what is the area of the triangle? In order to do this, okay, we can treat 18 like our base, but the height is going to need to go from the top straight down. We don't know what the height is yet. What we're going to do is we're going to create two right triangles. All right, if you look at just this piece here, we got two right triangles. This is H, this is 41. This whole bottom is 18. This altitude is going to cut it in half and create, each piece is going to be 9. Using this pink triangle, we're going to do Pythagorean Theorem. Pythagorean Theorem's coming back a lot. We're going to have to do h squared plus 9 squared equals 41 squared. Make sure that hypotenuse is by itself. When you do Pythagorean Theorem, I'm going to skip this, you're going to get 40. So our height is 40 centimeters. We know the height, we know the base. The area is 1/2 times the base times the height. And when you multiply that together, you're going to get 360 square centimeters. All right. It does mention that the altitude can be outside the triangle. That type of problem is going to happen when you have something like this. So maybe this bottom piece is 10 meters. You might have like two sets of dashed lines. Maybe this is 5 meters and this is maybe 2 meters. If you had a problem like this and you had to find the area, the base would be the 10, not the 2. The height is the one that's perpendicular. I know that the 5 doesn't look like it's perpendicular because it's not even touching, but this is going to be your height. All right, and then you would plug it into the formula. 2 is excess information. You wouldn't actually use it for anything. So if you had to find the area of this one, you do 1/2 times the base times the height, and you would get 25 square meters for this guy. So just wanted to show you where the altitude can be. It can be inside. It could be on the triangle as well. So if you have an actual right triangle, you know, and this is 2 and this is 10, you can easily find the area. The height is on the triangle, and you could find the area that way. So inside, outside, or on the circle, depending on what you have. Trapezoid is the next one. The area of a trapezoid. Remember that a trapezoid has two parallel sides. These two parallel sides are your bases, so B1 and B2. The other two sides are your legs. We're not really going to use the legs for much. The height is going to be the distance between the two bases, and the height will be perpendicular to both bases. A trapezoid has exactly one pair of parallel sides. An isosceles trapezoid has congruent legs. All right, so if it is isosceles, the legs would be congruent to each other. And the base angles would also be congruent. All right, so if it is an isosceles trapezoid, the base angles are congruent, meaning these two bottom angles along this base are congruent, and the two angles along the top would be congruent. The height is always perpendicular to both bases. So let me show you. In number 5, the area of a trapezoid is 32, the height is 4, one base is 6, find the length of the other. We're going to use this formula. Area equals 1/2 times the height times base 1 plus base 2. We know some of these pieces. The area is 32, the height is 4, so I'm going to replace the h with a 4. One of the bases is 6, the other base I don't know. I'm just going to call the other base b. From here, I'm going to multiply 1/2 times 4, I get 2. Times 6 plus b equals 32. You can either distribute the 2 and solve for b, or you could divide by 2. If you divide by 2, you're going to get 16 equals 6 plus b. And then subtract 6 and you'll get 10 equals b. 10, don't forget the units, 10 meters would be your base. All right, so from this part here, you can either distribute the 2 or divide by 2. Your choice. That would be your base. For this one, number 6, the bases are the two parallel sides. So this is definitely one of the bases. I'll call it B1. I'll call the other one B2. It doesn't matter which one's 1 and 2. These are not the height. 17 is not the height. Let's draw in a height. The height is going to be perpendicular and it'll go between the two bases. I don't know what that base is. I'm going to draw in another height here. Okay? What's going to happen is we need to find the height. What we're going to notice is if this piece here is 10, this piece here has to also be 10 because it's like a rectangle. And then we knew that this whole thing was 26. We've used up 10, which means that we have 16 left. This piece and this piece are going to have to be the same. All right, so if this is 16, cut it in half, this piece will be 8, and this piece will be 8. And now we can focus on one of these triangles. I'm highlighting it in yellow. Notice it is a right triangle. We're going to need to do Pythagorean Theorem. H squared plus 8 squared equals 17 squared. All right, and then that way we'll be able to find the height, and then we can find the area. So when we figure this out, we're going to end up with 15. All right, I'm going to skip some of this. So h equals 15. All right, we have the height, we have the bases, and now we can plug it in. The area is 1/2 times the height, 15, times base 1, 10, plus base 2, 26. And then you can type this whole thing in on your calculator, and you're going to get 270, and it'll be square inches for your units. All right, so that's how that one works. Then we have a rhombus or a kite. Rhombus is like a leaning square. Remember that I mentioned earlier that you can use base times height. So in a rhombus, you can still use base times height if you have those pieces. Sometimes you're going to be given the diagonals. So for a rhombus and a kite, you can use this formula. 1/2 times diagonal 1 times diagonal 2. The diagonals are the pieces that go from the opposite corners. The diagonals in a rhombus and a kite are perpendicular. Okay, notice we're going to be creating right triangles. More Pythagorean theorem to come. Because of this, 4 right triangles are formed, and therefore we will see that the Pythagorean theorem is often used. Pythagorean theorem is used often. So, what we're going to do is we're going to look at number 7 and number 8 in the next video because I'm running out of time. I'll talk to you soon.